We know that the production of iron and steel industry, the main source of main raw material is iron ore. You are the two types of iron ore. It is there: low grade iron ore, high grade iron ore. High grade iron ore anyway we can use directly into the blast furnace, but these are not abundant in the earth crust. For a low grade iron ore, we can use, but after enrichment of the iron only we can use. For that we have to do concentration, we have to do liberation, we have to use different techniques like crushing, grinding, and these all operation we have to do. In that what will happen, we can get the fines, but those fines cannot be used in the blast furnace. Those fines has to agglomerate. We have to increase the size of the fines by agglomerating process. In those agglomerating process, this pelletization process is more popular, because after pelletization, what are the product is there? After pelletization, we are getting the spherical balls. These are called pellets, green pellets. You know that one, because we have the good porosity, around 25% porosity is there. That's why these pellets are popular. So this pelletization, we are generally use pelletizer for producing the pellets. You know what are the different materials used for this making the pellets? Iron ore fines we'll use, water is there, and binder we use. So binder what we have used is bentonite here. So both contents we have to optimize that one, because if we are using the more bentonite, then along with the bentonite, some silica and other contents will be increased, so that it will be have a protected. You will get the problem. You have to remove those things. That's why water also optimum percentage should be there. So here in this experiment, what we are doing, that when we are checking the drop strength and crushing strength of the green iron ore pellets. Why it is important? So for productivity of the pelletizing plant, what is the main parameter which affect the productivity? That is the green strength. This green strength also depend upon the two parameters. One is drop strength, other one is the crushing strength. So drop strength is nothing but what we'll do. Why the drop strength? Actually, it is important. When you are seeing the pelletization plant, what will happen? After making the pellets from the pelletizer, these pellets will drop on where immediately it will fall on roller skin. From the roller skin again through the conveyor belt, it will go to the hardening area. So when it drops from the pelletizer, it will subjected to the impact. So from the height it is falling. So while falling, it should not break. For that, what we'll do, we also test in the laboratory whether it is having the impact strength or not. What we'll do, from a height of 450 mm, simply for calculating the dropping strength, it is very easy. Only thing, we have to drop this pellet from 450 mm height onto the steel plate. So suppose I want to check the drop strength of these pellets. What will do? I will make it fall. I have to leave this ball from 450 mm height. Then it will fall on the steel plate. So how many drops? It should not break when you are falling. It has to sustain certain number of drops. So that drops. That is called drop strength. It should not break when I am laying this pellet on the plate. On the steel plate, it should not break. How many drops it will sustain without breaking? That is called drop strength. So that is important. And one more we told, that is crushing strength. Why is crushing strength is also important? Because these pellets also subjected to compressive force, because of overlaying pellets on weight. That's why the crushing strength also it is important. So why here optimum percentage is required? Why it is very important to control the moisture? Why optimum percent of moisture is required? Suppose if your moisture percentage is optimum, what will happen? Whatever the pores are there, those pores are completely filled by water. If less water we added, what will happen? Some pores will be left with air. Then your capillary effect will be decreased. Then you will not get the strength. Like that, if more water when we are adding, more water what will form? It will form a coherent film. When it is forming coherent film, what will happen? It will neutralize the effect of the capillary. So there also you will not get strength. So in the video after this, demonstration will be given. Demonstration is shown for drop strength also, for crushing strength also. For drop strength also, it is very simple equipment. We are dropping the pellet from certain height, that is 450 mm. And for checking the crushing strength also, that equipment is shown number of times that pellets are tested for this drop strength and the pellets are tested for crushing strength, and you will be familiar for that. So no need to discuss again and again, because that will be cleared while showing the video. So in the by checking the compression strength, what we'll do, we will take a simple pan arrangement. There will be a left side pan, then will be a right side pan. It is a pan balance simply. In the left side pan balance, what we'll do, we have to keep that pellet in between the two jars. So for that arrangement is required, head screw will be there, means we are placing this pellet between the two plates, because we have to apply the force. That arrangement will be in the left side pan. Right side pan, what will be there? We have to apply the force on the pellet, means there one measurement jar will be there. One jar will be there, it is filled with water, it is having the measurement. So we can see the readings, initial reading what is the water, final reading what is the water. So measured jar is required, right side. So left side what is there? Your head screw arrangement is there. In that arrangement there will be two jars, lower jar and upper jar. You can call it that lower one will be the anvil and upper will be the upper plate. So in between these two plates, just will touch the pellet will be in between these two plates. Before doing the experiment, we have to touch this pellet like this. We should not apply any force. So right side will be the measuring jar is there. In that we have poured water. When we add extra water, what will happen? The force will be applied on the pellet. So at which force that pellet is taking, will note down. So how will get crushing strength directly? So initial reading we have to take. Initial reading means when the balance is equal, and the pellet is placed and then the balance is equal, that will be initial reading. For crushing the pellet, we have to pour the water. So we'll pour the water up to how much water it has taken to crush the pellet. That will be final reading. The final reading, initial reading, it will give you the crushing strength of the pellet. So it will be cleared when you are seeing the video. So this is the experiment number 8. We are determining the crushing strength and drop strength of green iron ore pellets. So we are taking the two measurements. We have to determine the two things. One is crushing strength and is the drop strength of green iron ore pellets. These green iron ore pellets also we will make. After that we will do the testing. We will find out crushing strength and drop strength. So while making the green pellets, what we are keeping the constant, what are the things we are adding? Actually for making the green pellets, what are the things are required? We need iron ore, we need water, we need bentonite, sodium based bentonite. So for making the pellets, 3 raw materials are required. You can see here iron powder is there. This is the sodium based bentonite, this is the binder, and we need water. We need water. These things are required. So in the first experiment, we are making the green pellets. We are adding water and bentonite also. So 3 things are there: iron ore, water, bentonite. Here one thing we are keeping constant, that water we are keeping constant. Water, how much we are keeping? 12% of iron ore. How much? What is the weight of the iron ore we are taking? We are taking 200 grams. We are making 5 samples, 5 different samples. In each sample we are taking 200 grams of iron ore. How much water we are adding? We are adding 12% of iron ore water. How much water we are adding? 12% of iron ore. 12% of iron ore means 200 into 12 by 100, it will come 24 cc. So 24 cc we are adding. In all the samples, we are adding the same percentage of water, that is 12% of water. What we are adding here? Here we are adding the percentage of bentonite. Initially 0% bentonite means we are not adding any bentonite. Here only iron ore will be there water will be there. There is no bentonite. And in this sample 2, we have iron ore, we have water of 12%, and bentonite we are adding 1%. 1% of iron ore 200 grams means it will be 2 grams. Like that, here also third sample, iron ore, 12% of water and 2% of bentonite, means 2% of iron ore, 4 grams. Like that, fourth sample, we are taking 200 grams iron ore and we are adding 12% of water, means 24 cc, and we are adding 3% of bentonite, that is 6 grams. And fifth sample will be iron ore 200 grams and water 12% of iron ore 24 cc and 4% bentonite we are adding, that is equivalent to 8 grams. So, in this experiment, we are taking iron ore and we are keeping the water percentage constant, that is 12%. 12% of what? Iron ore. 12% of 200 grams weight means 12% of water means 24 cc, and bentonite we are varying. Water we are keeping constant and bentonite we are adding. The bentonite is 0. How much we are adding? 0 to 4. 0, 1, 2, 3, 4. So, these are the weights of the bentonite. Now, for making the pellet, this information is required. How much iron ore we have to take, how much water we have to add, how much bentonite we have to add. So, for taking the weights, we have the balance here, we have the digital balance here, and raw materials also we have, iron ore we have, sodium bentonite we have, and adding the water. So, how much we have to add into this mix? 24 cc. So, 24, for adding the water, we are using the burette. So, we will fill the water from this, we will add water into this mix. So, we already told we have 5 samples are there. So, 5 trays are taken. This is the C, this is the first tray, and this is the second tray, and this is the third tray. This is the fourth tray, and this is the fifth tray. See here, we already weighed this iron powder. We have taken the iron powder and with the help of digital balance, we weighed the weight of this iron powder is 200 grams. So, for first sample 200 grams, water will add, but bentonite we don't add, 0% bentonite. That's why you can see here bentonite is not there. We have iron ore, no bentonite, we'll add water in this. In the second tray, we have 200 grams of iron ore and we'll add 24 cc water. Bentonite, how much we require? 2 grams. We already weighed this bentonite with the help of digital balance. Now 2 grams bentonite is ready to mix it. This is the 2 grams bentonite. So, in the third sample, 200 grams iron ore and 2% of bentonite means 4 grams. Here 4 grams, you can see bentonite is there. It is already weighed. Fourth one, 3% of bentonite means it is equal to 6 grams iron ore. So, 6 grams. Here fifth tray, we are adding 4% of bentonite. This is 200 grams, 4% means 8 grams. So, 4% bentonite is 8 grams bentonite is ready to add. For making the pellets, first we have to mix this iron ore powder and bentonite. So, to get the homogeneous mix. After that we are adding, then you will get a best pellet, totally it will be mixed. For mixing, suppose if you are taking any one container, put the iron ore, put the bentonite, just mix it properly, then it will give the homogeneous mix. That we will see that one. So like that, if you can mix manually also, but if you are putting this iron ore powder, this bentonite in one container, and if you just hesitate like this or vibrate like this, then what will happen? It will be properly mixed. In that mix, if you are adding water, then it will give you a homogeneous bentonite. Means bentonite will be mixed properly with the iron ore. You will get the good strength. If you are not properly mixing, then your strength, you may not get that much best strength. So in this experiment, this is the things what we have seen. We have seen the raw materials, and we are going to make green pellets. In the green pellets, we are keeping the water constant. How much water we are taking? 12% of iron ore we are taking constant. 12% of iron ore means 24 cc we are adding. In how much? What is the weight of the iron ore? 200 grams. What we are wearing here? We are wearing the bentonite percentage. That is from 0 to 4%. This is the first tray. We are not adding any bentonite, so here mixing is not required. So now we are coming to the second tray. In the second tray, we have iron ore and 1% of bentonite, that is 2 grams we added. For better mixing, what we are doing, we are putting in one container both iron ore and bentonite, so that it will properly mix. Now we are closed and we are mixing like this, so that you will get a uniform mixture of iron ore and bentonite. Again we are transferring this mix into the tray. Like that you can do for other trays also. This is the third tray. In this third tray we are adding 200 grams of iron ore and 2% of bentonite, that is 4 grams. In the same procedure we are taking into one container. Close the lid, just shake it so that it will give properly mixed. Like that you can do for remaining 2 trays also for getting the uniform mixture. So this is the fifth tray, final tray. 4% of bentonite will be added. Just shaking the mixer. And we are pouring into the same tray, because after this we have to add water. Now we are mixing the water of 24 cc from the burette. So we are adding water into the mix of iron ore and bentonite. Now we are adding 24 cc water from the burette. So now it is mixing properly, you can see. Now we are making the pellet. The mix is ready to bond. So proportionately that water is mixed, that's why the pellet is formed. So in this mix, binder is not there, only iron ore water is there. That's why it is little difficult to make the pellet. So now we are making the pellet. Now we are making the pellet of this iron ore and water. So binder is not there. We added water into the iron ore and we are trying to make the pellet. So like this we can make the round pellets. So we'll keep in the same tray so that it will not mix. Like that we will make number of pellets because we have to take the average reading of crushing. In case of crushing strength also, in case of drop strength also, we can't determine the strength for single pellet. That's why we want to make at least 4 pellets. So this is the procedure of making the pellet. Now we are making the pellets with iron ore without bentonite, 0% bentonite. This is the way of making the pellet. As soon as we are making the pellets, we have to test immediately, otherwise water will be evaporated. So in the green condition, we can't get the results. Now we are measuring the drop strength of these green pellets. These green pellets having iron ore and only water. 12% water is there. So this is the setup. This is the simple setup. See, this is the platform where we will keep this pellet. From this height it will fall. The height is 450 mm. In this it is small setup. You can see from here we will drop the pellet. Where? On the metal plate. You can see the steel plate it is there. In the steel plate it will drop. Only we have to see that how many drops it will sustain without breaking. This is in green condition. Now we are from 450 mm height. Now we are dropping the pellet. So it is not having binder. That's why in the you can see in the single drop it is breaking. But our aim, it should not break. It has to sustain number of drop. But within the one drop it is totally breaking. This is third one. Again you can see it is breaking. You can see the small cracks here. So it is breaking. Because it is not having any binder, 0% binder, only iron ore, powder and water. Same thing. So this is the pan balance. You can see left and right pan it is there. In left side we are putting the weight and right side we have a measured jar. In this water we have filled. Where we place this pellet, so we can place the pellet from this base and here you can place down this and so we have to keep the pellet between this base. This is like anvil and we'll make it down in this one because we are checking the crushing strength. So Just we have to touch the pellet. So now you can see pellet is in between this base and the top jaw. So in between these two plates, pellets is there now. Now see the balance. No, it is equally balanced. The first step is we have to equally balance, and the second step is we are placing the green pellet between the head and the platform. Now we are from the head we are making down. We want to touch the pellet. Now it is touched. So this is the procedure. First, initially we have to balance this pan balance, and after that keep this green pellet, and head we have to make it down to so that this top plate will touch with the pellet. Now we will the initial reading also will see what is the initial reading. One division is 100, so 3800. 3800 is the initial reading. Now we are filling the water drop by drop. So slowly we are applying the pressure on the pellet. So we are observing the pellet. When it will crack, that time we have to see the reading also. So slowly we are applying the pressure on the pellet by filling with the water.
Okay.
See, it is cracking. Now we will see the final reading. You can see the crack. You can see it clearly. It is cracked. Now we'll see the final reading. It is nearly 4090 because it is not coming up to. It is less than 4100. Now this is the third pellet. Here also you can see we made it equal. Left side and right side, both ends are now equal. Here what is the condition? We kept the green pellet between the bottom platform and the top platform. So here the pellet is in between the two plates. With the help of this head, we touched the pellet. So the pellet is in between these two plates. Balances are equal. What we will do? We will fill the water. Before filling the water, we have to see the initial reading. The initial reading is 3750. 3750. You can see here the reading is 3750. This is 3500. This is 4000. So it is 3750. Now we are filling the water and observe we are applying gradually the pressure on the pellet. So slowly the water is filling into this bottle. Force is applying on the pellet. Just to see how much water it will take to break this pellet. As soon as we observe the crack, we have to stop the water filling and see the final reading.
Yes.
So it is pellet is broken and we'll see the final reading. Like this, the total experiment we'll do. We have taken 4 samples. Green pellets. Now see, again we are clearing the procedure. How we have to balance after keeping this green pellet only. We have to make sure that it is balanced. After that, we lower this head and touch the pellet. Now it is touched. We are filling the water so the force will be applied. Initial reading we have already taken. That is 3800. And we are observing for pellet breaking. see crack is initiating slowly. Then very soon it will break. Broke. Crack is initiated. And we have stopped the filling also. Final reading will take. This is a 1% bentonite iron ore with 1% bentonite, and water is constant, that is 12% of iron ore 24. So 1% bentonite of PLCM with a pellet of 1%. We are checking the dropping strength. Now it is little deformed. And second one we are okay. This is also so second time let's see this one, this side. Now it is broken. One drop, two drop. Just deform this one. Third drop, you can observe that it is broken. Cracks, we can observe cracks. Sample. One drop. In two drops, it is broken. One drop. In two drops, it is totally broken. So initial reading 5673750. Now pellet is already in contact. Now pellet is in between these two plates. Now we are releasing the, we are filling the water slowly and applying the force on the pellet. So some crack is we are observing. Now it is broken. You see the final reading. Four one. It is broken. The adding reading will take 41 150 4150 ले सकते हैं. 2% maintenance. 2%. 1. 2. Second drop. 3rd drop. 1. 2. 3. 4. 1. 2. 3. 4. Up 2% rate. 1. 2. 3. 4. Now this is just for 2% bentonite green pellet. We are checking the crushing strength. So after balancing, touching the pellet. Now the pellet is between the plates. Now we are filling the water. Before that we have to take the initial reading. Initial reading we are taking. Same procedure, just we are filling the water and applying the force on the plate. And observe the pellet breaking. So it is broken. $3,950. Oh. The pellet is already contact between these two plates, and we are filling the water. Then we'll observe for the breaking of the pellet. It's cracked. It's cracked. Cracked. You take the final reading. 4450. So 3% bentonite green pellet. Again we're checking the drop strength. First drop. Second drop. Third drop. Fourth drop. Fifth drop. Okay, 3% bentonite. First drop. Second drop. Third drop. Fourth drop. Fifth drop. Sixth drop. Seventh. Eighth drop. Third sample. First drop. Second drop. Third drop. Fourth drop. Fifth drop. Of 3% of bentonite. First drop. Second. Third. Fourth. Crushing strength. Filling the water and applying the force on the pellet. Correct. When we are going to the literature, see in the literature also, they have taken the iron ore pellets. The relation between the drop strength and bentonite, we have seen here. Here, what they check? They check the drop strength. What is the variation here? They kept moisture is constant, that is 12%. The pellet size also constant, that is 12 mm. So when they are increasing the bentonite percentage in that iron ore, so what will happen? Slowly the drop strength is increasing up to 1.5%. You can see it at 1.5% bentonite is increased. The drop strength is increased. Why it is increased? Because due to the increase in the surface tension forces, there will be a, so without water, the clay cannot be activated. If water is there, then the clay activates, then it will bind. So only the clay is water. Water is there, then sufficient. If water is there, that clay will be. If you are adding more clay also, if water sufficient is not there, then the clay will not be active, then you will not get this strength. So here you are at 1.5%, sufficient water is there for the 1.5 bentonite, that's why the strength is increased. Here further increasing in the clay, further increasing the bentonite, what happened? Even the strength is not increased because here water is not there sufficiently for increasing the 2% of that bentonite. That's why that clay is inactive. That's why we are getting a less drop strength. So this is about the drop strength at bentonite. When we are increasing up to certain percent, 1.5% bentonite, the drop strength is increased because of the surface tension forces of the bentonite in water. There, bentonite in water is proportionate. That sufficient water is there for the bentonite to activate that clay particle, that we are getting good drop strength. But when we are increasing the water, when we are increasing the bentonite, but we are not increasing the water, we are keeping the moisture percent 12% only, but we are increasing the bentonite. There, some whatever the clay, excess clay is there, that is inactive because it is not getting water, sufficient water to activate. That's why the drop strength is decreased. Our values, when you are seeing the same thing with increasing the bentonite, the drop strength is increased after 2%, then it is slowly decreasing. The same reason can be applied here, so it is matching. With increasing the bentonite, the drop strength is increasing up to some maximum limit, then after that it is decreasing. When we are going to see the effect of green crushing strength versus bentonite. So when you are here moisture is 12%, we are keeping the constant. We are changing the percentage of the bentonite. When you are increasing the bentonite, what will happen? The crushing strength also increasing. It is from the literature. Why? Because the presence of water. What is happening? Presence of what? The bentonite providing capillary forces. So that is giving the strength. So here, this is the from the experiment, lab experiment with increasing the bentonite. The green strength is also increasing. It is also showing the same trend as in the literature. With increasing the bentonite, we are getting the crushing strength also, it is increased. What is we are varying the bentonite but keeping the moisture constant, that is 12%. Again we are going to the literature. There two things are taken. With increasing the moisture, the green strength, what is happening? It is increasing. It is increasing up to optimum percentage of the moisture, OMC, optimum moisture content. So after that it is decreasing. Already we discussed it. After, because more water if you are adding, why the strength is decreasing? After optimum, if you are increasing the water, then strength is decreasing because it forms coherent film, because that neutralizes the effect of the capillary. That's why the strength is decreasing. Here, why the crushing strength is increased? Because the degree of void filled by H2O is up to optimum. After that, it is after optimum, when increasing the water, it is decreasing. So it is shown, we are seeing two curves. One is for coarse size, other is for fine size. For fine size iron ore, we are getting the more strength. Obviously, when fine ore is made, there will be a more specific area, so you will get the more high strength. So here also, drop strength also we can see, it is increasing with increasing the moisture percentage. So in this case also same thing, fine size iron ore is getting more drop strength compared to the coarse size, because the same thing, same specific area is more, that's why we are getting the more strength. So here in the lab test also, it is shown that with increasing the moisture content, the crushing strength also it is increasing. Here we varied moisture content, but we are keeping the 2% bentonite fixed. Same thing here also, the drop strength, it is increasing with the moisture.